Hey boys and girls, so today we're going to be going over Unit 2, Lesson 8, just the second half of it. All right, so we're going to call today Day 2. I know that yesterday we were working on word problems that dealt with more than one variable. Today we're going to also work on word problems that deal with more than one variable. And then towards the second half of the lesson, we're also going to talk about consecutive even and consecutive odd word problems. All right, let's read number 5 and just jump on in. Kyle is 6 years older than Melissa. 9 years ago, he was twice Melissa's age. How old is Kyle now? So as I'm reading through this question, it looks like there's two unknown variables here, Kyle and Melissa. So I'm going to start off by just writing their names. Kyle and Melissa. Nowhere in the question does it tell me how old Kyle is. Nowhere in the question does it tell me how old Melissa is. I have to figure that out for myself. And that's okay. We'll definitely get that done. But since I don't know both, I'm going to at least start off by writing what they're eventually going to equal because I don't know who they are right now. All right. Anytime we see a word problem, we always cube, circle key numbers, underline the question, box math action words. So I'm going to do that right now as I read through each sentence again. All right. Kyle is 6 years older than Melissa. So Kyle, I'm just going to put a K right now for Kyle. So Kyle is a key word. It means equals. So Kyle is 6 years older than Melissa. So 6 is a key number. If he's 6 years older than Melissa, that means we want to add on years to his age. So again, I'm going to use addition to represent the keyword older. And then Melissa, well, I don't know how old Melissa is. It doesn't say that. So I'm going to let Melissa be represented by the variable m. So right now I really know how old Kyle is. He's going to be 6 years older than Melissa. So I'm going to fill that out. He's going to be 6 plus m. Okay, and we actually also just figured out how old Melissa is by letting her be represented by the variable m. So I'm going to let Melissa equal m. All right, that's good to go. Let's look at the second sentence. This part is very tricky. 9 years ago, he was twice Melissa's age. So again, all this information comes from 9 years ago. This is how old they are right now. Let me write that down. Right now, Kyle is 6 years older than Melissa. And then again, Melissa is just represented by the variable m. Now I'm talking about 9 years ago. So let me at least start off by writing that out. 9 years ago, this is how old they were. He was twice Melissa's age. Well, he is Kyle. So Kyle was, that's going to be Kyle equals twice Melissa's age. Twice is a key word. It means 2 times. So he was 2 times Melissa's age. We said that Melissa is being represented by the variable m. Okay. This information, one more time, is from 9 years ago. Very, very tricky. I can't use this information here in blue because this represents their ages right now. That tells me I have to come up with what their ages were 9 years ago. So here I go. Let me fill this in. So we have Kyle and Melissa. I'm going to take what Kyle's age is right now, and that's 6 plus m, and I'm going to subtract 9 from it. Because 9 years ago is in the past, that's subtraction. That's where negative numbers would be. So again, I'm going to take what his age right is. I'm sorry, guys. I'm going to take what his age is right now, and I'm going to subtract 9. That will represent his age 9 years ago. Same thing with Melissa. Right now, Melissa is M, but 9 years ago, her age was M minus 9. I have to take how old she is right now and subtract 9. That will give me how old she was 9 years ago. Okay. And then the question asks, well, how old is Kyle right now? That's the goal. How old is Kyle? We want to figure out how old he is right now. So if I want to figure out how old Kyle is right now, that means I have to solve for the variable m. So I can get that number and add 6 to it, and then I'm done. Okay, here we go. We're going to use this 9 years ago information to get solving. So I know that K equals 2 times M. Again, this is 9 years ago. Kyle was twice Melissa's age. So now I'm going to use this information and I'm going to plug it in to this equation that I've come up with from the word problem. So 9 years ago, Kyle was 6 plus M minus 9. Let me fill that in. He was 6 plus M minus 9. He was twice Melissa's age. 9 years ago, Melissa was M minus 9. So 9 years ago, Melissa was M minus 9. So I'm not going to write 2 times M, I'm going to write 2 times M minus 9 because all of this comes from 9 years ago. All right, and then from here, we would solve through and get our answer. So I'm going to draw my train tracks in, and I'm going to just start solving like we would any other question. So whenever I see parentheses, I usually think to multiply, but there's no coefficient out front except that invisible 1. And I know that 1 doesn't change anything, so I'm going to ignore that 1 out front, and I'm just going to go ahead and start combining like terms. So I have a positive 6 and a negative 9. In the calculator, 6 minus 9 is negative 3, and then I bring down that plus m. On the right-hand side, again, I'm seeing parentheses, and I know parentheses tell me to multiply or distribute. This one's different because there's a 2 out front. 2 will definitely change these numbers inside the parentheses. So I'm going to multiply the 2. 2 times m is 2m. 2 times negative 9 is negative 18. Okay, and now I just combine my like terms on opposite sides to continue solving through. I'm going to bring this 1m to the opposite side. I like bringing the smaller to the bigger. So the opposite of addition is subtraction, subtracting 1m on both sides. All I have left is a negative 3 equals 2 minus 1 is 1. So now I just have 1m minus 18. Well, if all of my variables are on the right-hand side, that means all my numbers should be on the left-hand side. So that means I'm going to move this minus 18 by making it a plus 18. I'm going to move it to the opposite side. All I have left is m equals negative 3 plus 18 is positive 15. All right, so it looks like m equals 15, but I have to be really careful to reread the question and make sure that's what the question was asking for. I know that m represents Melissa, but the question says how old is Kyle right now? Well, I know that Melissa is 15 right now because m is represented by that number 15. So m, let me get a different color here again. So m equals 15 for Melissa, but the question asks how old is Kyle? So Kyle is 6 plus m. 6 plus 15 is 21. So if I want to answer this question on the side, how old is Kyle? Kyle is 21 years old. And we are done with number 5. That was really challenging. If you need to re-watch this question on the video, please do that. And if you have any questions, you can always message us in Canvas. Okay, let's look at number 6. Number 6 is another really tough one. Take a minute and I want you on your own now to just read through this question and see if you can start cubing it or coming up with any unknown variables on your own first. So at this point, please press pause, and then once you've read the question and try to start it, then press play again and you can join back in. All right, boys and girls, so number 6, like we said before, is definitely tough as well. It takes a lot of careful reading to break down what this question is asking for. So I only just started the question. I have not finished it at all. If I read the first sentence, it says, in 3 more years, Miguel's grandfather will be 6 times as old as Miguel was last year. There is a lot going on there. So if I continue reading, it says when Miguel's present age is added to his grandfather's present age, the total is 68. How old is each one now? Okay. Nowhere in this question does it say how old Miguel is. Nowhere in the question does it say how old his grandfather is. And I can also see that I'm talking about two different timelines, his present age and then what their ages will eventually be. Okay, it's very similar to number 5. Since I don't know how old the grandfather or Miguel are, I'm going to let the grandfather be represented by the letter G, and I'm going to let Miguel be represented by the letter M. Okay, I know that when Miguel's present age, and again, this is how old they are right now, when their present age are added together, the total is 68. So again, if I want to go through, I can box all that important information. Let me grab a different color here. So when Miguel's present age is added to his grandfather's present age, the total is 68. So when I take Miguel, which is M, and I add that to the grandfather, which is G, the total is a key word, it means equals, is 68. So the goal is for me to somehow use this equation, okay? As we continue reading, we go back. The question itself says, how old is each one now? So I don't know how old the grandfather is. I don't know how old Miguel is. So the goal is to solve for M and G. Now, I already read through the first sentence and got started on cubing that down here in purple. So the grandfather will be, that's equals, he'll equal 6 times as old Miguel was last year. Miguel was last year. So the grandfather is G, that's the variable I chose, equals 6 times Miguel last year. 6 times, well, Miguel last year, that's in the past. Just like on number 5, that would be a negative number or that would be subtraction. So I'm going to take Miguel, which is M, and I'm going to subtract 1 from his current age, and that would be how old he was last year, minus 1. All right. So if I look back at the first sentence, the only piece I didn't use is 3 more years, and that was very tricky. Again, that's talking about in the future. 3 years from now, in 3 years, this will be true. But since that's in the future, it hasn't happened yet, instead of writing plus 3, because I know when we see the keyword more, we think addition, it's actually the opposite. I'm going to now subtract 3 because those extra 3 years haven't come yet. So again, it would be the opposite. Very, very tricky, very hard. Okay. And now I'm going to go back, and like I said before, we're going to use this equation to solve through. Well, M is Miguel, G is the grandfather. I just represented G with this new inequality here. That's 6 times M minus 1, and then again minus 3 at the end. So I'm going to take that and plug it in for G. I know that this is what G equals, so I'm going to replace it down below. So now I'm going to have M plus, instead of writing G, I'm going to write what G equals. It equals 6 times M minus 1 minus 3. And again, that whole thing should equal 68. And this is the equation that we're going to solve to get our final answer at the end. So I'm going to go through, I'm going to just drop my train tracks here, and I'm just going to start solving. If I look at the left-hand side of the equation, it's very busy. There's a lot going on here, so I want to clean this up. Anytime I see parentheses, I think multiplication. I'm going to look at the coefficient, that number in front, and it's a 6. So I'm going to distribute 6 to M and to the negative 1. 6 times M is 6M. 6 times negative 1 is negative 6. I'm going to bring down that plus sign because it's really a positive 6M. and I'm also going to bring down the m. All right, he was on the outside, it didn't go anywhere, so he just drops down. Same thing with the minus 3. It doesn't really do anything with the other terms, so he just drops down. And that's going to equal 68. Now that I got rid of my parentheses, I'm going to look for like terms. I have a 1m in the front, a positive 6m coming next, and then I have a negative 6 and a negative 3. All right, those are like terms, they're numbers. I can always combine those together. 1m plus 6m is 7m. Negative 6 minus 3 is negative 9. And that's going to equal 68. And then 2 more steps. I'm going to combine my numbers so they're on one side. All right, I have my variable on the left. That means I want to have my numbers on the right. So I'm going to change subtraction to addition. This cancels out. So now we have 7m equals 68 plus 9 is 77. Last step, m is on the left-hand side. In order for me to get rid of 7, well, the opposite of multiplication is division. So I'm going to divide 7 out, and that leaves me with just the variable m. Oops, m. Oh my goodness, I keep going off the page. m equals 11. But I have to carefully reread the question one more time, make sure I answered it. Question asks, how old is each one now? That means I want to know how old the grandfather is and how old Miguel is. So if I know that Miguel is 11, I can go back up top here and fill that in. I know that Miguel is going to be 11 years old. But the grandfather is a little more tricky. To get the grandfather's age, I have to use all this information. Again, I know that m is 11, so I'm going to replace that variable m with 11. So here I go on the side. It's going to be 6 times 11 minus 1 minus 3. Okay, when we type that into our calculator, this is a little tricky, so I'm going to show you how you would type it in. Here we go. I'm going to do 6 parenthesis, 11 minus 1, close the parenthesis, minus 3. And I get 57. So how old is the grandfather? He would have been 57 years old. And again, Miguel is 11 years old. Okay, if you want, we can even write that out in a sentence form. So grandpa is 57 years old. Miguel is 11 years old. All right. Again, this was really, really tough. It takes a lot of careful reading to work through this question. All right, if you feel like you need to rewatch any of this question, please feel free to do that. And if you're ready to move on, let's go to the last page. All right, so as we look here on the last page, we're working with consecutive integer word problems. I just went ahead and already wrote out some notes. Please feel free to add this to your notes. So we have consecutive integers are integers that come from one after another. All right, an example of that would be numbers 1, 2, 3, 4, 5. They come one after another. Okay, I'm going to get to this example in a minute. We also have consecutive even and consecutive odd integers. So that would be even integers that come one after another, like 2, 4, 6, 8. And then consecutive odd integers are odd numbers that come one after another, like 1, 3, 5, and 7. In order to solve word problems that deal with these type of numbers, we're going to look at what I wrote out here in purple for us, okay? The way that we come up with these expressions that I have in purple at the top and in purple at the bottom is by using the examples that we have here in our problem. So let's say 1 is the number that I'm starting with, all right? So how do I get from 1 to 2? Well, I would have to add 1, right? 1 plus 1 is 2. How do I get from 1 to 3? Well, 1 plus 2 is 3. Same thing, how do I get from 1 to 4? 1 plus 3 is 4. How do I get from 1 to 5? 1 plus 4 is 5. So in this example, the number that I'm working with is the number 1. And that's helping me get from 1 to 2 to 3 to 4 to 5. But sometimes I don't know what the number is that I'm starting with. And that's when we represent that with the variable x. So if x is the number I'm starting with, well, how do I get to the next digit? It would be x plus 1. Just like in the example, you add 1 to get that second number. Well, how do I get the third number? I take x and I add 2. Just like again, my third number here, I had to take 1 and add 2. Do you see the pattern, right? Plus 3 plus 4, x plus 3, x plus 4. So these are the expressions we're going to work with when we're dealing with consecutive integer word problems. If I'm dealing with consecutive even or consecutive odd, these are the expressions that we're going to use instead. And it's the same thing. I just used the consecutive even as the example here, but it works for both. So let's say I start with the number 2, right? How do I get from 2 to 4? Well, 2 plus 2 is 4. How do I get from 2 to 6? 2 plus 4 is 6. How do I get from 2 to 8? 2 plus 6 is 8. So again, right now in this example, the number I'm starting with is 2. But it won't always be 2. Sometimes we don't know. So when I don't know what something is, I call it x. So instead of writing the number 2, I'm replacing it with the variable x. Again, that's how I'm getting x plus 2, x plus 4, x plus 6. All right, so consecutive integers, we're going to use these expressions up top. If it's even or odd, we're going to use these expressions down below. All right, let's look at example 7. The sum of 3 consecutive integers is 27. Find the 3 integers by setting up an equation. All right, I'm going to cube this question just like we would any other problem that we read. So I see the keyword sum. Sum tells me to add. All right, 3 consecutive integers. This is huge. Integers are numbers. That's why I'm circling this. So if it's 3 consecutive integers, I should be using the first word that they gave us in the notes up top. These are the expressions that I want to think of when I'm working on number 7. And then again, when I add those 3 consecutive numbers together, it's going to be 27. So it will be 27. It is 27. Again, is a key word. It means equals. Okay, so right now I want to add those 3 consecutive integers together. These are going to be my 3 consecutive integers. You always start with the variable x. So I'm going to have an x. Next would be x plus 1. And after that would be x plus 2. So these are my 3 consecutive integers that I'll add together, and they're going to equal 27. So that's the equation I'm going to set up. Let's get started. So I have x plus 1 plus x plus 2, and that's going to equal 27. And then I just combine my like terms and solve. So here we go. We have 1, 2, 3 x's. So I have a 3x. I'm going to go back. I have a positive 1 and a positive 2. 1 plus 2 is 3. And again, that's going to equal 27. I'm going to drop my train tracks, and I'm just going to start solving through. So here we go. We're going to subtract 3 on both sides to move it over. The opposite of a positive is a negative, or the opposite of addition is subtraction. Now all I have left is 3x equals 24. And then last but not least, the opposite of multiplication is division. Divide both sides by 3. X equals 8. But I have to be careful. Cubing, circling the numbers, boxing the action words, and underlining the question. The question says find the 3 integers. I want to find what those numbers are going to be. So here we go. We have our first number, our second number, and our third number. The first number was x. The second number was x plus 1. And the third number was x plus 2. If x is the variable 8, that means my first number was 8. Next, 8 plus 1 is 9. 8 plus 2 is 10. So find the three integers. These were my three integers, 8, 9, and 10. And then number 8, last but not least, now we want to find three consecutive odd integers. Okay, so again, I'm going to cube the question, find the sum that tells me to add three consecutive odd integers. And again, that says it's going to be 3. Is a key word. It means equals, and it's going to equal 3. If I want consecutive odd, if I look back up at the top of my notes here, I see that consecutive odd is represented by these expressions in purple down below. So I'm going to use x as my first number, x plus 2 as my second, and x plus 4 as my third. First, second, third number, first, second, third number underneath. All right, and then I'm just going to jump in, set up my equation, and start solving. So I'm going to add x, x plus 2, and x plus 4. And that's going to equal 3. And then just like before, draw my train tracks and start solving. I'm going to combine like terms. I have 1, 2, 3 x's. And then I also have the numbers 2 and 4. 2 plus 4 is 6. And that's going to equal 3. And then again, I just continue solving through. I'm going to subtract 6 on both sides. This cancels. All I have left now is 3x equals -3. The opposite of multiplication is division, so I'm going to divide out 3 on both sides, and x will equal -1. But again, I want to figure out what those three integers are going to be. All right, so I'm going to just make sure that I plug those back in. So on the side, I have my first, second, and third numbers. My first number was x, second number was x plus 2, and the third number was x plus 4. Okay, oops, so sorry guys. So here we go, x was a -1. My next number, well, -1 plus 2 is +1, and -1 plus 4 is +3. So this would have been my 3 consecutive integers. Okay, an easier way to remember what these expressions will be for the consecutive even or the consecutive odd would be the adding of the 2 and the adding of the 4. Okay, if you can remember consecutive even, I'm adding 2, I'm adding 4, those are even numbers. If you can remember consecutive even, it's the same thing as consecutive odd. So hopefully that might help you just a little bit. All right, make sure you guys are studying all of these notes and submitting those lessons on Canvas, and have a great day.